I'm Martínez from Fujitsu Research of Europe, and in this video I will present the main ideas of our submission to the SympTEMIST share subtask. I made this work together with my colleague Nuria Garcia Santa. The contents of this video are described in a paper entitled as this first slide. So if you want to know more details about this submission, please refer to this paper as well as the other references that we will show in this presentation. The SympTEMIST share subtask proposed a challenge on recognizing symptoms. The training data contained Spanish text with all symptom mentions tagged. I included an example of the data in this slide. The machine translated English sentence that I made is there to give you an idea of what the data looks like, in case you don't know Spanish. We made our named entity recognition systems based on large language models. The model that we finally used for the final submission was based on RoBERTa. For a final submission, we used the three techniques that we are listing here. I will talk about these techniques in the following slides. The first of the techniques that we used was BPE dropout. If you don't know about BPE or Byte-Pair Encoding, it is a method to split words into subwords. This helps us control our vocabulary size and avoid having rare words appearing in the texts. The method was first introduced for neural machine translation, and it is now used in many different NLP tasks, with a special mention to large language models like RoBERTa that we used in our submitted systems. BPE dropout, on the other hand, is a training method that can be applied on models using BPE. It consists in randomly dropping some of the subwords or merge operations from BPE. As a result, this has a data augmentation effect, since we can get multiple sequences of subwords from a single text, and so it multiplies the training data. The regularization effect provided by BPE dropout usually improves the final results of the system. If you want to know more about BPE and BPE dropout, please refer to the cited articles. Another technique that we used is applying conditional random fields. CRFs are well known in the NER field and have been used since before deep learning became popular. Even in the LLM era, CRFs are used to improve the results of named entity recognition systems. We used CRF with a BIO schema and forbid the transitions from outside to inside tags by initializing the transition matrix with a bias in this particular transition. Probably the less known technique of those that we used is the Sub-Subword feature method that consists in producing the subword embedding of each subword from a set of some of its n-gram features. The n-gram features that are used are chosen using a feature selection algorithm. This technique has been used in neural machine translation to improve the results in low resource settings. We think that we were the first to apply this method to named entity recognition. Since pre-trained models include trained word embeddings, we first trained the feature-to-embedding network to produce embeddings similar to those of the model using mean squared error. After that, we could train the NER models normally. We conducted a few experiments to choose the systems that we would submit to the challenge. Some of those experiments are shown in this slide. For our experiments, we made a training, validation, and test set from the provided data. We split the documents into sentences, and after partitioning the data, we had 11,000 sentences for training and 500 for validation and 500 for testing. The first thing that we tried was using a softmax layer on top of the LLM model that we are mentioning in this slide. After that, we also tried BPE dropout as we described in a previous slide. This improved the performance greatly, but after having a look at the produced results, we realized that the model was producing impossible transitions, such as outputting an inside tag after an outside tag without going through a beginning tag. We decided to use CRF to avoid this problem. This improved the results, but we could still see some impossible transitions. We decided to include a bias to forbid these impossible transitions from the beginning. This solved the problem and improved the results. After that, we also tried the Sub-Subword features method described in the previous slide. This did not improve the results in our testing data, but since the challenge allowed multiple submissions per team, we still submitted this system. The results of the experiments are shown in the table. And so we finally submitted these two systems to the challenge. The results reported by the organizers are displayed in this slide. We do not know the ranking of the challenge as of yet, but we were told that we got the best and second best recall values of all the submitted systems. Since we did not specifically optimize for recall, we thought this was good news. Also, the system, including Sub-Subword features, got slightly better results than the other system. So it was good that we decided to submit that one as well. This was all for this short presentation. Thank you for listening.